Shalim bin Saufi.
My name is Muhammad Akhil Fitri bin Anwar.
Hi, my name is Aisha Elena binti Zainuddin.
My name is Nurul Balkis binti Abdulillah.
Assalamualaikum and good morning to everyone. We're going to be starting our presentation with our presentation outline, which is first, introduction, reasons for logical equivalence, third, converse, inverse, and contrapositive, fourth, determine conditional statement equivalence, fifth, alternative conditional statement, and lastly, its conclusion.
Two statements are said logically equivalent when they have same logical content. Notation for logical equivalent is shown at the image 1.1.
Prove either logic or not. In order to prove one statement, firstly, we need to understand what is a logical equivalent. Logical equivalent is as two statements are considered logically equivalent if they have the same truth value under all interpretation. In other words, two statements P and Q are logically equivalent if and only if P is true and Q is true, and P is false whenever Q is false. Then we will have to figure out ways to prove one statement by first construct a truth table, then find the truth values and determine whether the two statements are identical or not. Lastly, write a reason. So let's look at example 1. Given question, proof P and Q is logical equivalent to a negation of P implies with negation Q. For the truth values, I'll be using 1 as a true statement and 0 as false statement in the truth table. Next, construct the truth table. The top row of the truth table is the header. Start by identifying the individual variables involved in the statement. Then we need to separate each of the statement until we get the biconditional of the statement. To determine how many rows to construct truth table, we'll be using 2 power of n, where n is 1, 2, 3, and so on. If the statement is true and both of the statement is identical, then both of the statement is logically equivalent. Write a reason. There are two reasons for logical equivalence of the statement. The first one is the truth value for the statement 1 and statement 2 are identical. The second one is the last column, which is the biconditional, shows tautology. What is tautology? Tautology is a statement that always true as it shows on the biconditional column of truth table if it's logically equivalent. Either one or both of the statement can be written. So reason for example 1 is the truth value for P and Q and negation of P implies with negation Q are identical. P and Q and negation of P implies with negation Q are logically equivalent because the biconditional shows tautology.
Converse. The definition of converse is generated by swapping the conclusion and the hypothesis. This is the example for converse. The statement, if Aiman use an umbrella, then he will not get wet. So we change it to a symbol. So P and Q. P Aiman use an umbrella and Q Aiman get wet. So in symbolic form, P implies negation Q. Condition statement, P implies negation Q. So we change it to converse statement, which is negation Q implies P. After that, we have to change it to a statement. If Aiman will not get wet, then Aiman use an umbrella. For inverse is negating of both of hypothesis and conclusion. So here we use the example 3, same as for the converse. If Aiman use an umbrella, he will not get wet. So we change it to symbol. P, Aiman use an umbrella, and Q, Aiman get wet. In symbolic form, P implies negation Q. Conditional statement, P implies negation Q, and we change it to inverse statement, which is negation P implies double negation Q. So double negation we change to Q only. So we get negation P implies Q. So after that we change it to the statement. If Aiman not use an umbrella, then he will get wet.
So today I'm going to be explaining about contrapositive. So how do we obtain contrapositive? So in order to obtain contrapositive, you must negate both the hypothesis and the conclusion. And the conclusion must be in front and the hypothesis must be in the back. So basically, contrapositive is both inverse and converse of the statement. So for example, I'm gonna using a very basic symbol here, a very basic statement, which is P implies Q. So in order to get the contrapositive, you must negate both of the primitive statement and also change the position. So and then you will get the answer, which is not Q implies not P, which is the contrapositive of the statement. So for the next example, so the question is find the contrapositive of the statement below. So the question is, if Ayman uses an umbrella, he will not get wet. In order to solve this question, first we must find the primitive statement. So P, which is Ayman using an umbrella, and then Q is Ayman get wet. In primitive statement, we can't use negative statement. So that's why the Q is Ayman get wet. You must make it positive. And then change it into a symbol, which is P implies not Q. And then we must negate the statement. So by negating it, we get the first step is not Q implies not P. And then after simplifying it, it's gonna be Q implies not P. So if you change the statement into sentence back, we will get that if Ayman is wet, Ayman doesn't use an umbrella. So by observing this truth table here, we can see that the original statement is logically equivalent to the contrapositive because they have the same truth value. And also the converse and inverse is also logically equivalent to each other. So that's how you recognize which is contrapositive and which is converse or inverse.
We also can read the conditional statement P implies Q as the following. There are 7 alternative conditional statements that we have to know for this topic. First, if P then Q. Second, Q if P. Third, P is a sufficient for Q. Fourth, P is a sufficient condition for Q. Fifth, P only if Q. 6. Q is necessary for P. 7. Q is necessary condition for P. 8. Q whenever P. And the last one is Q from P. Let's go to the example 1. What are the contrapositive, the converse, and the inverse statement? The home team wins whenever it is raining. So let's look at the statement together. The statement will be Q whenever P, but actually Q whenever P is the same concept with P implies Q, which is if P then Q. For the statement if P then Q, the statement will start from antecedents and conclusion at the back. But for the statement Q whenever P, the statement will start from conclusion and antecedents at the back. First, converse. Converse is obtained by interchanging antecedent and consequent. Since the statement P implies Q, so that the symbol for converse will be Q implies P, and it is written as if the home team wins, then it is raining. Second, inverse. Inverse is obtained by negating antecedent and consequent. The symbol for inverse will be not P implies not Q, and it is written as if it is not raining, then the home team does not win. For the last one is contrapositive. Contrapositive is obtained by both interchanging and negating the antecedent and consequent. That means we converse and inverse the statement at the same time. So the symbol for contra will be not Q implies not P, and it is written as if the home team does not win, then it is not raining. Finally, to conclude our lesson, we are able to understand the meaning of logical equivalent, and we can know the two statements are logically equivalent or not by using truth table. Other than that, we are able to differentiate conditional, converse, inverse, and contrapositive. And the last one is we can learn to solve the problem involving alternative conditional statement.